Hey everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help us out over here, and it also helps us reach others in need of assistance with these topics. So what we're going to be covering in this video is we're going to be covering calculus and how to calculate derivatives using the quotient rule. And this will be our first part of this series with the quotient rule. So we are tasked with finding the derivative of the expression shown here. So usually when you are utilizing the quotient rule, you're going to have some expression divided by another expression. So in order to utilize the quotient rule, what you're going to have to do is we are going to have to set up some substitution here, and we are going to call our function f, or our variable f, and we're going to set that to our numerator, the entire numerator value, which would be x to the fourth plus 3x squared minus 6. And then we set this g variable, or this g equation, equal to what's in the denominator. So it'd just be x squared plus 1. So to fully utilize and apply the quotient rule, when we are taking the derivative with respect to x with our substitution variables in there of f over g, this is what we end up with. We end up with g times df dx, so the derivative of our f with respect to x, minus f times the derivative of g with respect to x, and then all of that divided by our function of g squared. So we already have f and we have g, so let's just plug in here and utilize the quotient rule to find this derivative. So you might want to leave some room here because this one's going to be quite long to write out. So we would have g, which is just x squared plus 1. And then we have the derivative with respect to x of our f equation, which is x to the fourth plus 3x squared minus 6. And then minus all of f, which is x to the fourth plus 3x squared minus 6. All of that times the derivative with respect to x of our g equation, which is just x squared plus 1. And then all of this completely divided by g squared, which is x squared plus 1 squared. So we got some simplification to do, and we actually have to find some derivatives right here of these two expressions, which these expressions are of the simplistic form of a to the power, or a times x to the power of b, which when you take the derivative of this portion, it is just going to be your power dropped in front multiplied by original constant of a times x to the power of b minus 1. Okay, so now I don't need this top portion anymore because I have my function right here, my derivative expression right here. So I'm going to have x squared plus 1, it remains the same, no derivative taken there, times the first portion here, drop the power. We would have 4 times x, and then subtract 1 from that power, so 3, and then plus 3 times my power of 2, which I'm just going to write 6 there, and then x to the power of 2 minus 1, which is just 1, so we can just write x. And then whenever we have a constant with no variable we're taking respect to, well, that just becomes minus 0 for that 6 right there. So that's my first one. And then the second portion here remains the same for the first part of the second portion, which is x to the fourth plus 3x squared minus 6. And then my next portion, derivative with respect to x of x squared, well, that is just simply 2x, drop the power, take 1 off the power, so it becomes 1. And then once again, we have a constant with no variable, so plus 0. And then all of that divided by x squared plus 1 squared, well, when you write that out, or simplify it out, it becomes x to the fourth plus 2x squared plus 1 here in the denominator. Well, let's go ahead and take our multiplications through for each portion here, simplify this down even further. Because technically you could leave it like this if you wanted to, but it's a lot better to simplify it down. So my entire top portion, my entire numerator becomes x, or 4x to the fifth plus 6x cubed, because all this is algebra now at this point, plus 4x cubed plus 6x minus off 2x to the fifth minus off 6x cubed plus 12x. And once again, all that divided by my x to the power of 4 plus 2x squared plus 1. Well, we can combine some like terms here because we have x to the power of 5, power of 5, and power of 3 all over the place. So we can start combining stuff here, and let me scroll just a little bit further here, and then we can finally arrive at the final answer, which is the derivative of the starting expression, which is equal to 2x to the 5th plus 4x cubed plus 18x all over x to the power of 4 plus 2x squared plus 1. And that is my final answer. And this shows you how to use the quotient rule, which is pretty much whenever you have some expression being divided by another expression, you just have to substitute in an f and a g variable, and then applying the quotient rule, it becomes this section here, and then you just have to fill in and then work your way through the problem. So I hope this video was helpful. And if you want to see more problem solved this Friday, please check out the other videos on our channel. Also, if you haven't done so already, please like this video, leave a positive comment below, and subscribe to the channel because all of that really does help us. Thank you for watching, and I hope you have a fantastic day.